Hello, welcome to this lesson of our study of partial differentiation. Okay, so in this video we'll just go through some basic examples of partial differentiation. Okay, so if you have not subscribed to the channel, kindly subscribe to support the channel. Okay, all right, let's start. So given that f of xyz is this one, we are supposed to find fz, fy, and fx, meaning the partial derivative of f of xy with respect to its respective components or variables. Okay, all right, so let's start with the first one. Okay, the first one, fz. Now fz is simply differentiating f of xy, and f of xy is given by this f of xyz rather. Okay, is given by x sine of the expression y plus 3z. Okay, now with this, fz is simply differentiating the whole of this with respect to z, and in that I have to look through it and find out where my z is, and z is inside the expression of the sign. Okay, but x here is constant, so I have to just write x. Okay, and then I will differentiate the sign with respect to the z. Okay, so you could see that inside the sign you have y plus 3z, so I have to differentiate that bracket first. Now with respect to z, so when I differentiate y, I'll get 0, so I don't have to talk about that. When I differentiate 3z with respect to z, I'll get 3, and differentiate the sign, I'll get cos of the same expression back. Okay, this one, so simply fz is 3x cos of y plus 3z. This is very simple, right? So that is it. Now we go to our fy, and that one is very simple as well. Okay, that one to x, then you differentiate the sign and the function that is inside the sign with respect to y. So inside the sign we have y plus 3z, so when I differentiate that with respect to y, I'll get 1 times then cos of y plus 3z. Okay, so the answer is x cos of y plus 3z. And then with the fx, that's the simplest one, that is why we did it to be the last. Okay, now with that, you see that f of xyz is just x sine of something. Okay, and apart from the x aspect, there's no x again. Okay, I mean f of xyz is this, is given as x sine of y plus 3z. And now with this, if I want to differentiate the whole of this with respect to x, then these are all constants because there's no x here, so I have to only differentiate this with respect to x, and I'll get 1, so I'll get sine of y plus 3z. Okay, and that will be the solution to that question. Now let's move on to another question. If f of xy is given by this, then you are supposed to find del f del x and del f del y. Okay, so already my f of xy is given by 2s cubed y plus x sine of y. Okay, so now with this, my fx, which is the first one, or del f del x, okay, del f del x is simply given by differentiating the whole of this with respect to x. Now come here, like we said in our previous video, we said that whatever variable that is present apart from what you are talking about is a constant. Okay, so here y2 is a constant, so I have to get something like this. I differentiate s cubed with respect to s, and I'll get 3 s squared then times 2y, and that will give me 6 s squared y. Okay, I hope you get it now. Plus differentiate the whole of this with respect to x, and that one too will give me sine of y. Okay, I hope this is very cool. Alright, so let's move on to the second one. Already our f of xy is given by 2x cubed y plus sine of x sine of y, sorry. So our second question, which is the b part, del f del y, is simply differentiating the whole of this with respect to, and that will be 2s cubed plus s cos of y. I hope you understand this. Okay, it's very simple like that. Okay, so let's move on to the last question of this video and we'll be done for the lesson. Okay, last question is saying that if f of xy is this, okay, then find 1 over f of x plus 1 over f of y. There are some other conditions at s equals 1 and y equals 2. That's the actual question. Okay, so you are supposed to find the value of this at those points. Okay, so what you have to do is simplify fx and fy. Okay, so know that f of x, let me go to the next page and do it there. F of xy is given us s cube y minus sy cube. Okay, so simply what you can do is fx is, by now I know you know how to differentiate partially. Okay, y cube like that, and my fy will also be equal to s cube minus 3xy squared, right? So we are supposed to find this, the value of this 1 over fx plus 1 over fy at x equals 1, y equals 2. Okay, so first of all, what you can do is you are supposed to find this. You just put 1 over, then fx is what? So 3s squared y minus y cube. Okay, and plus 1 over, this one is s cube minus 3xy squared. Okay, so we are supposed to evaluate this at x equals 1, y equals 2. Okay, s equals 1, y equals what? 2. So with that, you have to simply put our values in. So I have to put 3, then x is 1, so 1 squared is 1, minus y is 2, so 2 cube is what? 8. Okay, and plus 1 over s cube is 1 minus 3 into 1, y squared is what? Just 2 squared, so I have 4. Okay, so this will give me, after simplifying this, I will get negative 13 over 22. So I'm supposed to go through the simplification by yourself and you'll be able to get it. Okay, so this is a simplification of the solution to the question here, this question. Okay, all right, so thank you, and don't forget to subscribe to the channel and support the channel as well.